Understanding carbide burrs for cylinder head porting. Cylinder head porting is a precision machining process used in automotive and engine building to improve airflow through the intake and exhaust ports of an engine's cylinder head. This enhances performance by reducing restrictions and optimizing the flow of air and fuel mixture. Carbide burrs are essential tools for this work because they are made from tungsten carbide, an extremely hard, durable material that can withstand high speeds and temperatures without dulling quickly. Unlike high-speed steel, HSS, bits, carbide burrs excel in removing material from hard metals like aluminum and cast iron, which are common in cylinder heads. Choosing the right carbide burr is crucial for achieving smooth, efficient porting without damaging the head, causing excessive vibration, or creating rough surfaces that could harm engine performance. The wrong burr can lead to clogging, overheating, uneven cuts, or premature tool wear. Below, I'll break down the key factors to consider when selecting a carbide burr for cylinder head porting, step by step. This includes the head material, a primary driver, cut type, shape, size, and other practical considerations. Assess the cylinder head material. The material of the cylinder head dictates the burr's aggressiveness and design to ensure clean cuts and minimal issues like clogging or chatter, vibration. Most performance engine heads are either aluminum, lighter, more common in modern engines for better heat dissipation, or cast iron, denser, more durable, often found in older or heavy-duty engines. For aluminum heads, aluminum is softer and more prone to producing gummy, stringy chips that can clog the burr's flutes, the cutting grooves. To achieve smoother cutting and less clogging, opt for double cut or diamond cut burrs. Double cut burrs have two intersecting helical patterns, one right hand and one left hand, creating smaller, more manageable chips that evacuate easily. This reduces heat buildup and allows for faster material removal without bogging down the tool. They're ideal for roughing out ports quickly while maintaining control. Diamond cut burrs feature a finer, crosshatch pattern mimicking diamond abrasives, providing an even smoother finish right from the start. They're especially useful for aluminum because they minimize surface tearing and produce a polished edge with less effort. Use these for finishing passes after initial roughing. Avoid single-cut burrs here, as they can load up with aluminum chips, leading to inefficient cutting and potential burr breakage. For cast iron heads, cast iron is harder and produces brittle, powdery chips that are easier to manage but can be abrasive on tools. Single-cut burrs may suffice for basic porting, as their single helical flute provides a shearing action that's controlled and less aggressive, reducing the risk of overcutting or creating excessive heat in this tougher material. However, double-cut burrs are often preferred for efficiency, especially in high-volume work or when time is a factor. The crosscut design speeds up material removal by breaking chips into smaller pieces, making it faster overall without sacrificing too much control. Diamond cut can be overkill for cast iron unless you're doing ultrafine finishing, as it might wear faster on such abrasive material. In general, start with the head's material as your baseline, test a small area if possible to see how the burr performs before committing to a full porting session. Determine the right shape. Cylinder head ports have varied geometries, oval intakes, round exhausts, sharp bowls, and curved runners, so the burr shape must match the contour you're working on. Common shapes for porting include cylindrical, straight or end-cut 4 straight sections of ports or flat valve faces. Choose a diameter slightly smaller than the port, e.g., 1/4 inch to 1/2 inch for most automotive heads, to allow for overlap and blending. Ball-nosed or spherical, ideal for rounding bowl areas under valve seats or creating smooth transitions in port floors. The rounded end prevents flat spots and gouging. Tapered or cone-shaped, for diverging port sections or valve guide areas. A 14 to 18 degree taper mimics common port angles. Oval or tree-shaped, specialized for following the natural oval shape of intake ports without excessive material removal on the sides. Flame or inverted cone, for undercutting valve seats or cleaning sharp edges. Tip: start with a set of multiple shapes to cover the entire porting process, rough with cylindrical, finish with ball-nosed. Measure your ports with calipers or porting templates to ensure the burr fits without binding. Consider size and specifications. Diameter and length. Burrs range from 1/8 inch to 3/4 inch in diameter. For cylinder head porting, 3/16 inch to 3/8 inch is standard for automotive engines, e.g., small block Chevy, or Ford heads. Longer shanks, 1.5 to 2.5 inch, provide better reach into deep ports, but ensure your tool's collet can grip securely. Undersized burrs allow for better control and less aggressive removal. Shank size, most are 1/4 inch for die grinders, match to your tool. Flute length and count, longer flutes for deeper cuts, more flutes, e.g., 4 to 6, for smoother finishes but slower speeds. Coating and quality, look for uncoated or tin, titanium nitride, coated burrs for heat resistance. High-quality brands like those from USA or European manufacturers ensure balance to reduce vibration. Imbalanced burrs can cause uneven ports or tool failure. Other practical factors. Tool compatibility and safety. Ensure the burr is rated for your RPM range. Most die grinders hit 20,000 to 30,000 RPM. Use with a foot pedal speed control for precision. Always wear PPE, goggles, respirator, gloves, as porting generates fine metal dust. Workpiece preparation, clean the head thoroughly, secure it in a vise. Use cutting oil or coolant for aluminum to prevent galling. Testing and technique, start at low speed to feel the burr. For porting, aim for 0.005 to 0.010 inch passes to avoid heat distortion. If the burr chatters, it's too large or the RPM is wrong, downsize or adjust. Budget and longevity, expect to replace burrs after 1 to 2 hours of heavy use. Invest in a kit for variety, but prioritize based on your most common heads. By considering these factors, material first, then cut type, shape, and size, you'll select a burr that delivers efficient, high-quality porting results. For aluminum heads, remember to prioritize double cut or diamond cut for that smoother cut and reduced clogging. For cast iron heads, single cut works for control, but double cut boosts efficiency in most cases. To see all our carbide burrs in stock, including a full range of shapes, sizes, and cut types tailored for cylinder head porting, visit our website today. We have everything from starter kits to professional-grade options ready to ship.